Electrical certification comes in various levels, each tailored to the type and complexity of the electrical work involved. When dealing with low-voltage systems, typically those operating below 50 volts, specialized certifications might be available. Examples include Certified Low Voltage Electrician, or CLV, Certified Network Cabling Installer, or CNCI, and Registered Communications Distribution Designer, or RCDD. For high-voltage work, generally defined as systems operating above 50 volts, the most prevalent certification is the Journeyman Electrician License. Acquiring this license involves significant training and practical experience. While a specific basic level certification that permits high-voltage work doesn't exist, some states offer apprentice electrician licenses or certifications. These can serve as stepping stones toward obtaining a Journeyman Electrician license. It's crucial to understand that even with a basic level of certification, you might still bear liability for the electrical work you undertake. Consulting a licensed and qualified electrician for any high-voltage tasks remains the safest approach. If you are occasionally encountering situations, such as needing to replace a plug on a power cord, it's generally not advisable to proceed without proper training and certification. Even seemingly simple tasks can present dangerous electrical hazards. The safest course of action is to continue engaging a licensed electrician for any high-voltage work, which helps ensure safety and limit potential liability. In the United States, electrical work is governed by the National Electrical Code, or NEC, which is a set of standards published by the National Fire Protection Association, or NFPA. The NEC provides guidelines for safe electrical installations. State and local jurisdictions adopt and enforce the NEC, often with amendments specific to their needs. To become a licensed electrician, one generally has to complete an apprenticeship program. These programs combine on-the-job training with classroom instruction. Apprenticeships typically last 3 to 5 years. After completing an apprenticeship, one can then sit for a licensing exam. Licensing requirements vary by state and locality. Licenses can be for journeyman electricians or master electricians. Journeyman electricians are qualified to perform electrical work under the supervision of a master electrician. Master electricians can work independently and supervise other electricians. Continuing education is often required to maintain an electrician's license. This helps electricians stay up to date on the latest codes and technologies. Unlicensed electrical work can be dangerous and may violate state and local laws. It can also void insurance policies. Electrical safety is paramount. Always energize circuits before working on them. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. When working on electrical panels, maintain proper clearances and avoid contact with live parts. Grounding is a critical safety measure. It provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Grounding systems must be installed correctly and maintained. Arc flash is a dangerous phenomenon that can occur when a short circuit creates a high-energy electrical explosion. Arc flash can cause severe burns and other injuries. Proper arc flash protection, including arc-rated clothing and equipment, is essential when working on energized equipment. Electrical testing instruments, such as multimeters, are used to measure voltage, current, and resistance. These instruments must be used correctly and calibrated regularly to ensure accuracy. Wiring methods must comply with the NEC. Common wiring methods include non-metallic sheathed cable, or NM cable, rigid metal conduit, or RMC, and electrical metallic tubing, or EMT. Each wiring method has specific applications and installation requirements. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. These devices must be properly sized and installed. Ground fault circuit interrupters, or GFCIs, protect people from electrical shock by detecting ground faults and interrupting the circuit. GFCIs are required in wet locations such as bathrooms and kitchens. Surge protection devices, or SPDs, protect electronic equipment from voltage surges caused by lightning or other events. SPD should be installed at the service entrance and at sensitive electronic equipment. Electrical panels must be properly labeled to identify circuits and breakers. This helps with troubleshooting and maintenance. Electrical maintenance is essential for ensuring the safe and reliable operation of electrical systems. Regular inspections, testing, and cleaning can prevent problems and extend the life of electrical equipment. Energy efficiency is an important consideration in electrical design and installation. Using energy-efficient lighting, appliances, and motors can reduce energy consumption and save money. Renewable energy sources, such as solar and wind, are becoming increasingly popular. Electrical systems must be designed to safely integrate renewable energy sources. Smart home technology is becoming more common. This includes devices that can be controlled remotely, such as lighting, thermostats, and security systems. Electrical contractors must be familiar with smart home technology and how to install it safely. Electric vehicles, or EVs, are becoming more popular. Charging stations must be installed safely and in accordance with the NEC. The NEC is updated every 3 years. It is important for electricians to stay up to date on the latest code changes. Electrical safety training is essential for all electricians and electrical workers. This training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. In addition to the NEC, other standards and regulations may apply to electrical work. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. Electrical work can be dangerous, but by following safe work practices and adhering to the NEC, electricians can protect themselves and others from electrical hazards. The specific requirements for electrical certification and licensing can vary significantly from one state or locality to another. It's essential to check with the relevant authorities in your area to determine the exact requirements for the type of electrical work you intend to perform. In many jurisdictions, different types of electrical licenses exist, such as residential, commercial, and industrial. The scope of work permitted under each license type can vary. Some jurisdictions also offer limited licenses for specific types of electrical work, such as fire alarm systems or low-voltage systems. These limited licenses may have less stringent requirements than a full electrical license. When considering electrical work, it is important to understand the difference between single-phase and three-phase power. Single-phase power is typically used in residential applications, while three-phase power is typically used in commercial and industrial applications. Three-phase power is more efficient for powering large motors and other heavy equipment. The voltage levels used in electrical systems can also vary. In the United States, common voltage levels for residential applications include 120 volts and 240 volts. Common voltage levels for commercial and industrial applications include 208 volts, 277 volts, and 480 volts. It is important to use the correct voltage level for the equipment being powered. Electrical systems must be designed and installed to meet the specific needs of the application. This includes considering the load requirements, the environmental conditions, and the safety requirements. A licensed electrical engineer can help with the design of complex electrical systems. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and prevent electrical shock. Grounding systems must be installed in accordance with the NEC. Bonding is another important safety measure. Bonding connects all metal parts of an electrical system together to ensure that they are at the same electrical potential. This helps to prevent electrical shock. Surge protection is important for protecting electronic equipment from voltage surges caused by lightning or other events. Surge protection devices should be installed at the service entrance and at sensitive electronic equipment. Arc fault circuit interrupters, or SIs, are designed to protect against arc faults, which are a common cause of electrical fires. SIs are required in many areas of the home, such as bedrooms. Tamper-resistant receptacles are designed to prevent children from inserting objects into the receptacle. Tamper-resistant receptacles are required in new construction in many areas. Smoke detectors are essential for alerting occupants to a fire. Smoke detectors should be installed in every bedroom and on every level of the home. Carbon monoxide detectors are essential for alerting occupants to the presence of carbon monoxide, a deadly gas. Carbon monoxide detectors should be installed on every level of the home and near sleeping areas. Electrical safety inspections are important for identifying potential hazards and ensuring that electrical systems are safe. Electrical safety inspections should be performed by a qualified electrician. When hiring an electrician, it is important to check the credentials and make sure they are licensed and insured. It is also important to get a written estimate before the work begins.